So this is number 7. And it kind of shows the y-axis and the x-axis like that. But vector A and I think they're saying that this is 15 degrees. And vector B also at 15 degrees. Oops, not 14, 15 degrees. Suggesting these two things are at right angles to each other. And we are to find vector D, which is 3.6 times A plus B. Is that how you guys interpret it? But they want the vector answer. So here's how I would do it. I'm going to treat these two vectors as if they are right angles to each other. And I'm going to treat vector B as if it lies along the x direction, and vector Y as if it vector A as if it lies along the y direction. And then whatever I get for my answer, I'm going to shift it 15 degrees. And then compute my answer relative to x and y. I'm not sure how you were supposed to give your answer. Were you supposed to give it in terms of I hat, j hat notation? Is it just the magnitude? The figure shows the vectors, find D. How did you guys have to put it in?
The answer was 5.73, 5.9.
So you had to give IJ notation or XY notation. All right. So here's how I would go about solving it. First, I'm going to ignore the coordinate system. And let's see. Kind of redraw it like that, with this one being 7.2 units long, and this one is 4 units long. 3.6 times A. So, I mean, it's not to scale. Is that okay with you guys? No? All right. This is just to try and get the angle relative to the vector B and to get the magnitude of D. So from this moment, I am looking to try and find the yellow one. The magnitude's easy. I'm going to get that right from Pythagoras. 4 squared plus 7.2 squared. This angle from here to here, not so hard either. I'm going to get that from the inverse tangent of 7.2 over 4. I am confident somebody out there could probably tell me what these are. I could break out my calculator. I don't want to. Still going to need that magnitude, though. So you got John? You got a calculator? I see you pushing buttons.
Yeah, no.
Maybe it's 8.
Maybe it's 8?
Maybe.
Somebody says maybe it's 8.
8.2369.
I got 8.2369. 5. You guys are all looking at me. Did you do it? Look, I don't want to be. I'm just looking at the other folks who are not even nodding in agreement. So, I mean, 7 squared plus 4 squared. Not tough here. 49 plus 16. I think 8's in the right ballpark. So, you said 235?
2.65.
Well, that's a whole lot of numbers. But I think in intermediate parts of a calculation, you should leave as many pieces as possible. So now that I've done that, I'm going to take the 60.9 And recognize that since this has been shifted away from the x-axis by 15 degrees, I'm going to subtract 15 degrees from 60.9. And when I do, I get, I don't know, 45.9? So that means this has to be 45.9. Now I'm going to take and kind of get rid of some stuff here that I don't need anymore, like, oh, I need all of that, so I want that, I want that. I don't need this anymore. I don't need this anymore. There we go. Now, clearly not drawn to the appropriate scale, but that doesn't matter. My next job is to figure out the two components. And there's going to be a component along this way and a component along that way. And this will give me both the horizontal and vertical component. So the horizontal will be 8.2365 times the cosine of 45.9 I hat plus 8.2365 times the sine of 45.9 j hat, or whatever notation they would like you to put it in. I think that will give you the appropriate answer. And since it's 45.9, you know, it's probably 5.8 or 5.9 for each of those. I mean, it's got to be 0.7 or 0.71 is the sine and cosine. So close to 45 degrees. Here's how I would do it. The first thing I would notice is that because he's standing on a slope, and I don't know how high he is, but I do know how high he is compared to how far away it lands. They gave me some trig to use here for that. So this is 15 degrees. He is, say, standing right here, but this is 1.75 meters above, I assume, the slope. So that's where the arrow gets released. And the arrow is launched at 50 meters per second. And an angle of 20 degrees. All right, so I would start by setting up my little chart here. I'm a big believer in the old chart, even if it doesn't help V and H. Now, Cameron suggested that we just reorient the whole thing to the slope, but that's going to change the direction of the acceleration and will require that we find the component of the acceleration in both dimensions. There's no reason you couldn't do that. It is not particularly different. It does require that in the horizontal and vertical direction now you will have an acceleration, each one of those a part of g. So I'm not sure if that's better or worse. I wasn't planning on working it out that way. But if you'd like to see that presentation, it might be interesting. So maybe a different day. But even if we did that, it would give us the distance along the slope. It wouldn't give us where it is along the ground. You know, either way, we can get the answer because we know trig. So I'm going to set this and call this R. I'm going to set this and call this, for right now, delta Y. Actually, no, I shouldn't do that. Not to be rude, but let's call this H. So that delta Y is H plus 1.75. Well, guys, I haven't dealt with the direction part at all. I'm just saying from here to here has got to be h plus 1.75. Is that okay? Now, as I continue, the initial y velocity is going to be 50 sine 20 degrees. The acceleration is going to be 9.8 meters per second squared, even though I'd rather use 10. The range, I don't really know it, so I can put r, but I know it in terms of h. In terms of h, based on the fact that tan 15 has to be h over r, I can say that r is h divided by tan 15. Now, so I'm going to put h over tan 15. And Vx is going to be 50 cosine 20 degrees. All right. Now, yeah, I should establish direction now. When I do that, all of this has got to be considered negative, and this has to be negative. Everything else will be positive. And go ahead and figure out what tan of 15 is, 50 sine 20, and 50 cosine 20. They're all just numbers, and we might as well, we're going to get some kind of numerical answer here. So I'm going to start with asking, what is tan 15? 268? 0.268. What is 50 sine 20? 17 point what? 1. What is 50 cosine 20? 47? All right. Now, I know on the right side I'm going to get h over 0.268 equals 47 times t. So I can say that t is equal to h divided by, what is 47 times 0.268? I'm sorry, I just can't hear you.
12.6.
Thank you. All right, so now I have an expression for the time. On the left side, I'm going to go ahead and put together a relationship that has time in it, but I'm going to use h over 12.6, which I think will give me negative h plus 1.75 equals 1/2 times negative 9.8 times h over 12.6 squared plus 17.1 times h over 12.6. Now, there's nothing pleasant about this, but this looks like it's going to provide me with a quadratic in terms of h. Now, it would have been nice if the archer wasn't 1.75 meters tall, because then I could have factored out an h. This suggests there might be more than one answer. I'm willing to bet one of the answers is negative, but that's pretty early in the process, so I'm not sure. But I'm going to go ahead and move on, okay? Get a solution. But I'm kind of out of space here, so you guys don't mind if I go to another sheet, right? So just 17 point. That 77, which is now here, 77.01, and recognize that the range is 77.01 divided by the tan of 15 to give us the horizontal range to where it strikes the ground. And even that wouldn't be the length along the slope, but I'm not really sure what they wanted. So let's find this. This would be the horizontal range. We're just dividing it by 0.268. 287? In meters? So if this is what they were looking for, the horizontal distance to target, then I would type in 287. If they wanted this, we still got more trig to do. So I didn't read it that closely. Is 287 good enough for you guys? You guys could do the rest anyways. That was what they wanted? They went to 2 significant places, so they went 290. Now, again, I'm a little curious. I'm a curious kind of person. I still want to know why the math suggested there was 2 answers and why one of them's negative. I think I know the answer. I think it's what happens if the arrow was shot at a downward angle instead of an upward angle, because it'd be shot right into the cliff or right into the hillside. And I think that's where it comes from. But suggesting that it landed just slightly below, but I'm not going to, hurry my, I know that when you put a negative sign for this velocity, it would reverse the 2 roots. If you look at the math, that's true. However, physics stopped right about here. Just to be honest with you. Yeah, there's a math problem after this, and it was an involved math problem, and you might not like the fact that 290 is the answer. But that's where the physics ended. And like I said, the only thing that became interesting to me afterwards was trying to see, well, what would possibly be the meaning of there being 2 answers? Because again, that's taking it away from the math and going back to physics and trying to interpreting the physical meaning of the answer. But I like that kind of. I'm sorry, we're adding all 3 together. Vector A, and what number is this? This is 4. Sorry, 4. Vector A is 18 units long and points entirely in the y direction. So if I was to write out it, I would write 18 at, say, 90 degrees from x. That okay? Which really just gives me 0 I hat plus 18 j hat. Any questions about that? All right, vector B, if this is the negative y direction, vector B is 30 degrees towards the x direction from negative y and has a length of 12 units. Is that okay? So I could write 12, 30 degrees 2x from negative y. But that's going to be 6 I hat. And let's see, square root of 3 over 2, right? So 6 square root of 3 j hat in the negative direction. Is that okay so far? Yeah, I'm just using that the sine of 30 degrees is a half, so half of 12 is 6. And the cosine of 30 degrees is square root of 3 over 2 times 12 would be 6 times root of 3. I'm kind of cutting corners here, but I thought that would be okay with all of us. We good? Vector C, we don't know. It's a question mark. So, question mark. So I'll have the C in the x direction, I hat, and the C in the y direction, j hat. I do know, though, that when I add these together, my resultant has 0 in the y direction and is negative 7.5 in the x direction. So I see a route to figure out what cy and cx are. Do you guys see the route? So I'm thinking 6 plus cx equals negative 7.5. And 18 minus 6 root of 3 equals 0. Oh, I'm sorry, plus c. Equals 0. Now this would give me a way to figure out cy and cx, to which I can go back now and find out what that vector must be. So I'm going to pause. If you guys have the picture in front of you, I see no reason why I should have to draw it, but this one might do better with the little picture, so I'm willing to jot one. Mostly because it's pretty asymmetrical. So I'm thinking F is supposed to look like that, and E is supposed to look like that. And there we go. So F, which is this vector, has, it's negative 1 I hat plus 2 j hat. And E is going to be 1 I hat plus 1 j hat. And I'm looking for G, which looks to be 0 I hat plus 3 j hat. That's the answer.
That's the answer?
It's got to be. It says,
No, there's something about
use the components to determine the direction. Oh, the direction of G is in the y direction. It's just J.
it was like an 8. The answer's 71, but I couldn't get past.
Oh, I'm sorry. You're right. I'm sorry. Excuse me. They want the angle between E and F. I didn't read the question part. I just went all the way to C apparently and didn't. All right, so we want the angle between those two. Fine.
See, it's hard. I got that.
It's not hard. If I were to do this, I'll do it the long way because I don't know a short way. This angle plus that angle is the total. And that suggests inverse tangent of 2 over 1.
Yep.
No, 1 over 2. So, and the other one is 45 degrees.
Yeah.
So what is the inverse tangent of 1 over 2? Not in radians.
26.5.
26.5? So our answer's got to be 47 degrees.
Well, the answer is 71.
I'm sorry, I said 47. It should be 45 plus 26.5 and then converted to 2 significant places, right?
Yeah, well, yeah, I guess.
So I would say 71.5 or 72 degrees.
Yep.
All right. Question, I don't like this question, but okay. It's all the stuff we've done though. Question B, use components to determine the magnitude of G. We did that. And use components to determine the direction of G. We did that.
That was the one that answers 71.
Well, it's got to be 3 units long. And it's got to all be in the J direction. So we did B and C. Right there. Oh, you're welcome. Nobody else asked any questions. Might as well. I'll have negative h minus 1.75 equals negative 4.9 times h over 12 is 12.6 12.6 squared plus I forgot 1 thank you times h over 12.6. I see absolutely no reason not to go ahead and combine the number parts that are here. So if you would please, 4.9 divided by 12.6 squared. It's going to be small, or you can multiply through everything by 12.6, but you don't really gain much of an advantage. So what is negative 4.9 divided by 12.6 squared? You said 0, 0?
Negative 0.03.
I'm going to need more decimals than that. Give me like 2 more decimals. All right. That okay with everybody? H squared. Plus, what's 17.1 divided by 12.6? H. I have to get everything to one side. Everything okay with that? Hello. All right. There's nothing pleasant about this. And I know some of you would have just graphed it and used that. But here we are. This is what it leads to. So I don't see anything helpful, but it looks like I'm still going to have inside here, inside the radical, all the numbers are positive. So when I take that root, I'm going to get something that is, looks like I'm going to get one negative root and one positive root total. So I don't know. Can I count on you guys to figure out what H equals, or should we do this in parts? I bet money right now, if I ask the room, I will get, I think, 5 or 6 different possible answers. So just take an extra few moments of happy time, and let's see if we can narrow it down to just one value for H. So I would assume to get the answer, if you come back over here and you look at this original function that we have, if this velocity had been negative and you trace that down, it would have made this positive, and that would have reversed the 2 roots. So if the person aimed downward 20 degrees on the 15-degree ledge, this would have given us the answer for where it struck the ground. It's a ridiculous idea because basically the guy's shooting himself in his foot. But that's the mathematics of it. That's what the other root could signify. All right. That was largely not very fun.